Thought we'd do a little video today about Rebound. We've talked about it in some other videos. Um, I emphasize a lot about Rebound in the car and why it's important. And I feel like a lot of guys maybe don't really like a lot of Rebound. And I don't know that we need a lot, but we're getting into some decent Rebound in these cars, and it's helping. And I think we need to, and I think it's helping for multiple reasons. And we might be able to back off a little of the Rebound as we venture down that road of preload in the front springs. So we might be able to play with that as our load numbers get better. We might be able to have a little less Rebound because we're really controlling less overall spring load in the car by preloading them springs or changing or basically using a load number. So we might see that. I still like a car that gets on and off the springs. Typically in the past, we've never had enough Rebound to control that. So we're going to talk a little bit about Rebound in general. Rebound is, of course, when you compress the shock in, it'd be compressed in and it's coming back out. That's the Rebound side of the shock, So when we get on or get on the right front, it doesn't release back to the left rear. It doesn't get off the nose as quick. That's right. And we're going to specifically talk about right front Rebound. So basically there's three different kinds of Rebound. We have low speed Rebound, high speed Rebound, and linear digressive. Okay. And based off of them, two of them, we have 0 point, which is also important. It's not really, it's something that happens in a shock that has Rebound in it. So that's what we're going to talk about. And then if we got a little time left, we might talk a little bit about tuning. We don't need, all Rebound's not created equally. So just because somebody's gone in and jerked a bunch of bleed out of the shock or stacked a bunch of shims on doesn't mean that that amount of Rebound is going to be good for the car. Okay, doesn't mean that it's going to be, that shock is going to be good for the car, because if the shock struggles at processing fluid from the compression to Rebound side through the shim stack, the car will not make grip. Okay, so there is some ugly Rebound. There is some, we've had some stuff that looked really well on the dyno, raced really poor, and vice versa. But for the most part, the Rebound looks pretty good on the dyno, races really well on the car, and it's balanced in the shock. So that has worked well for us. Okay, I see other people, they come to me and they say, "Oh, my car is struggling," and I look at their stuff, I dyno it or whatever, and it looks pretty decent, but it's not racing very well. Okay, well, some of it, different brands, I've been in enough, I can kind of tell why, what's going on, why it's going on, but in other cases, no. So there's so many builders out there, and there's so many racers out there, and I know a lot of guys are not using us. So, I mean, this is information to help you get better at what you do, either through us or through your current guy, but you need to understand these things, and that's why I'm going to try to explain them well. So we're going to go over low speed Rebound. I got a little drawing here. It didn't turn out real well, but it is what it is. But so we got our little dyno sheet here, okay? This is our forces, so we're going to call this 0. And I didn't really put them on there, but it'd be 100, 200, 300, 400, 500, 800, okay? And these are our dyno speeds, 1, 5, and 10, okay? About drop that. So we're going to call this low speed Rebound, okay? And we're going to call this linear digressive. Okay, and our high speed, I kind of screwed it up because I should have drew the high speed one first. So high speed Rebound isn't that great, okay? And I'll explain it off of this. Okay, we're going to call this 3 inches. Okay, and it's running through right through here, and we'll call this 100 pounds. We'll call this 400 pounds. And we'll call this 350. Okay? So here we have a shock that builds, and this is the Rebound average. So I did that wrong, I'm sorry. We're going to call this 100 pounds. And this about 300 pounds. So I'm off a little, okay? So this 3-inch number. So we're going to say at 1 inch we're 100 pounds, okay? This is a shock we want to build because it's got good balance between high speed and low speed. It's running out about 500 pounds. It's 100 pounds at 1 inch. It's probably about 280 here. And this is enough to control a car. Lateral forces and rebound, you know, on say a 600-pound spring, 550 to 600. This is controlling it. This, you think, okay, would control it better because it's got a lot more low speed and it's got a little more high speed. But typically, and this is more of a linear digressive type build. You'll hear guys say, well, it's linear digressive piston. It looks good on the dyno, builds a lot of, you know, the 3-inch number might be like at 350 and the 4-inch number might be 400, or the 10-inch number might be 400. Okay, but the problem with this is, you know, basically it's a 400-pound shock because this low speed is so high that if you hit a bump, it just blows off. Okay, so it's not, because we're not really, it's like being a weightlifter and only going in and working on upper body. You know, you got a lot of upper body, you got chicken legs. Okay, so you got to have some strength in the overall to support what's going on here. Okay, you may not see those high speeds on the racetrack, but that's not important because what we're talking about is a shim stack. You know, a bunch of shims that are stacked up here, and we're going to blow them off, but we want some strength in the stack. So we got to have some 10-inch number in the build, okay? So, but it's got to be balanced. It can't be overly heavy, okay? That's the same problem with the high-speed rebound, okay, which we used to kind of do some high-speed rebound stuff, and we thought it was good on heavy fast tracks. But in all reality, which I think it was fine, but as the track slowed down, the low speed went away in the shock. So even though you might have been making, you know, 100 pounds at 1 inch, you know, and 300 pounds at 3 inch, and 800 pounds at 10 inch, as the track, because you had so much bleed in the shock, as the track slowed down, your numbers backed off too, because you wasn't seeing that high speed, and it took the high speed to create the low speed. Okay, typically the case. This, typically not. This is so preloaded up, it'll build the low speed. But like I said, when you hit a bump, it tends to just blow the stack open. So you end up on a 400-pound shock, okay? Because you're not controlling it through here. This is kind of like a hair trigger on a gun, so it wants to go off, okay? So you got to be careful with that deal. The reason we want rebound is because let's say we're on a standard racetrack, and you know it's really fast, and we got lateral force in the car. Well, the car gets over on the nose and it stays there, okay? Because we're carrying speed and we're pushing it down on the nose, left rear's up, okay? Well, when it slows down, we don't get that posture and we don't get that attitude, and then the car goes away on us. It gets tight on throttle, the down position comes up, and then the car just struggles through the center, it struggles on throttle, sometimes it struggles on entry. We're tight on entry. So we've got to carry some rebound. So over time, what we've done is we've softened the spring, okay? Well, softening the spring literally increases the rebound, okay? But the car becomes so soft now it wants to bottom out on the racetrack. So this is where the load numbers have come in. We started basically increasing that poundage that the soft spring's seeing in the down position is keeping the car off the racetrack. I mean, we're raising our ride heights. You know, we're raising the front of the car up if we're not preloading against the shock. So we're increasing our load number, which is increasing our down number, okay, which is making the car run at a slower speed, with more load in it. It's keeping it off the racetrack, and it's making our rebound seem higher. Okay, so it's telling you the car wants more rebound. Okay, so you balance that out on a softer spring. And I'm tending to think the way the car sits on the springs in the front, that this may be a little bit of an advantage. Okay, we've had good success, you know, on a 550, 600 spring with the proper piston and the proper amount of low speed. We've had real good success. So I don't know that we just need to always be on a 450 and a load number situation so much, because we've had good rebound. Okay, so I see a lot of cars that are on a 7-8 type rebound, maybe a 10, you know, and the car, you know, it's got to be on a 500-pound spring in order for it to be balanced out. Okay, so it's either not good rebound or the proper rebound. So a little bit, well, let me rephrase a little bit about rebound. We have high-speed rebound, we have low-speed rebound, we have linear digressive rebound, okay? This one was low-speed rebound. I didn't draw out the high-speed rebound, but basically, you know, if we're shooting for a 1-inch 100-pound number on a low-speed rebound, well, we're shooting for the same thing on a high-speed. You know, it may only take... I don't know if I can draw upside down. We only take 400 pounds here to create this 100-pound 1-inch number on a low-speed shock. But on a high-speed shock, you know, it's going to take 800 pounds to control it. Okay, so in order to create this 100 here, we got to be 800 here. Okay, but that doesn't work so well because as the car slows down, as the speeds slow down, then this number decreases right along with the speeds, because it takes this much force to make this much low speed. Okay, then your linear digressive is just kind of like a loaded gun. This is more of an asphalt deal, in my opinion. Something that's really smooth and slick, you can get away with it. But on a typical dirt track, I think it has too much texture to make it work. Okay, there are guys out there that have done this. There's certain cars that are running around with a ton of low speed in them. We didn't really cover the 0 point. The 0 point.
Oh, Corey just said, can you talk about 0 point rebound side?
Okay, so I don't know if I can really draw that very well, but you have a rebound open line, okay, and then you have a rebound. This will be the rebound clothesline. Well, from 10-inch back to about 3-inch, the rebound clothesline is supposed to mimic. We'll just draw it in there like this. It's kind of supposed to mimic that open line, okay? But then it comes down here. It doesn't, and then it comes back up on the compression side. So it doesn't come back to 0, okay? And this is what creates the 0 point in here, okay? Basically, 0 is created. This is like the, I don't know if it's proper, but the more complex definition, okay? As the shock, you know, it has an acceleration and a deacceleration all in one stroke, okay? So on the compression stroke, the shock has to accelerate out to speed, and then at some point it has to deaccelerate before it gets out to here. So in this stroke, we have acceleration, deacceleration, okay? So that's what this is, acceleration, deacceleration. It's the shim stack pressuring up and opening, and the shim stack depressuring and closing, okay? So in the rebound stroke, you know, it's like if I was going to punch you in the nose but miss by this much, I'd have to swing really hard, but I'd have to slow down so I didn't hit you, okay? Well, here's your nose. So accelerate, deaccelerate, and what you want is you want your shim stack to open and close, okay? But as it's coming back and it's closing, the pressure gets to where it can't hold it, so it shuts. And that's what creates this 0, okay? And the pressure that's left over on the 0 is greater than the compression bleed is going to flow. So it creates a 0 point, okay? Because it's already higher than the compression bleed. That's where the 0 point comes from. Now here's the low end definition of that. As the zero increases, the shock's ability to hold the car there longer also increases. Okay, so I often refer to this kind of like the blow off on an air compressor. The more you turn the spring down, the higher the blow off. Okay, the more preload we put in the shock to create more zero, the more it will hold it there. So a 0 point shock is kind of based on bump stop stuff. Okay, so you want a higher 0 point in the bump stop because you want to hold it on the bump in load all the time. So that's the 0 point part of this. Okay, was there any other questions by chance? Okay.
No.
So the 0 point is, that's what we call a gorilla fist. I ain't got that shirt on, but that's what we call a gorilla fist. So sometimes we'll call a shock out right front 1-100, which is the 1 inch dyno number. So you might see a 50, 75, 100, 125. That's the 1 inch dyno number. When we go to a right front GF, then it'll be a 200, 300, 400, 500 number. Okay, that's the 0 point. Okay, so that's what you see in our stuff, and that's kind of explaining what it is. And the gorilla fist stuff is becoming more popular in all classes, except for mod lights. It's becoming more popular in B mods and A mods, and we're getting up there. Now here's the problem that we got to do. We got to tune the rebound, the right front spring, and the left rear drive number together. Okay, so let's say you have a right front Gorilla Fist 300 and a 500 pound spring. So let me write that on there. So right front GF. I'm going to go ahead and make it a 500 because it's a little. So that's the shock. It's 500 at 0, and we're going to be on a 500 pound spring. And we're going to say a typical car, we'll just do a preload car. We've got 200 pounds of extended load, left rear. Okay, so this car right here would be right front 500 spring, 200 preload. This would probably be a car that turns better than it needs to. Okay, so depending on the car, there are some cars out there that are way tighter than others, and there's some cars out there that turn way better than others. So we're just going to say kind of average car. This is too softly sprung, too much rebound, not enough left rear. Okay, so if this car turns too well, okay, so this car, this guy called in and says, well, I'm lacking drive, and this is what he had in, we'd be increasing this right front spring. Okay, so we might go up to, say, a 600 pound spring. 600 pound spring. I don't know if that looks like a 6 or
It's
not.
backwards.
Oh. 600 pound spring. We go up to a 600 pound spring. Okay, well, this added some drive to the car. So we went a couple of clicks here. It depends on how well the car turned, but we're going to say it turned really, really well. So we went a couple clicks here and no clicks there. Okay, so we gained a little left rear in the car, we gained a little drive, and we took 2 clicks of turn away from it. Okay, so we're working our way towards being balanced. Okay, once we get a car that turns good enough, so if we're going to go out here and race on this track, and this condition is what we see 80% of the time at this track. Okay, so we're going to go to Beatrice, Nebraska, and this is the way the track's going to be 85% of the time, moisture level. Okay, the car only needs to get to the corner good enough. If the car gets to the corner better than that, it makes it easier to drive. Okay, not necessarily faster or with more speed, but easier to drive. Sometimes that's good, sometimes it could be a little better. So we get to the corner good enough. Okay, this is right front Gorilla Fist, 600, 200 pounds of bite. We can't make this car any faster without changing these 3 parameters. If we change one of them, all we're going to do is make the car tighter. So if we go down in spring, we'll make the car, it'll free the car up, it'll turn a little bit better, but we'll lose drive. Okay, if we go up in bite number, well, we're just going to make the car tighter. If we go up in extended load, we're just going to make the car tighter. Okay, if we go down in rebound, we're just going to make the front of the car tighter. So this car turns. So in order to make it faster, we have to step it up. Okay, we may end up on a little more load number here, or we may end up on a different spring rate depending on where we're at. Okay, so we got to balance the car between left rear drive or extended load, right front spring, and right front shock rebound. Okay, so when you get a shock and you put it on the car and it kills drive, and you tell your shock guy you didn't like it because it killed all your drive, and he asked what you did, and you said you took it off, well, you ain't getting anywhere that way. So you got to balance them out. Rebound, when you put rebound in the car and it kills drive, it's not always a bad thing. So we need to tune with rebound, not just on the right front, but on the left front and on the right rear. And by doing this, we hold more load into the tires, we hold more given spring rate from lateral motion into the tires, which makes our car easier to drive. We can cut under people, we can turn the race car. So I'm always preaching, drive is not so important, turn is. Okay, so if you got a car that turns really, really well, you can add drive to the car, you can add front spring to the car until it doesn't turn really, really well. Okay, so most importantly is drive. I feel like the car needs a lot of drive in it. I said that backwards, see? I screwed that up. Car needs rebound in it. Car needs the ability to turn. It's so much harder to turn a car than it is to drive it forward. Okay? We know less about the front of the cars than we know about the rear of the car. Okay? So the easiest thing to do to make the front work better versus all the roll center stuff and all that is to add rebound to it. Okay? And if your shock guy is giving you good rebound, then the car will respond to it well. If it gives you bad rebound, even though it's rebound, you push shock in and shaft never comes out, and you put it on the car and the car races horrible, and it's not just because horrible doesn't mean, oh, it killed all my drive, it just races horrible. It's too rigid, to shear traction, because you can add rebound and just go and shear all the front grip. Okay, so with that being said, there has to be a give and take. You push, let's say you got 100 pounds of gas in the shock, and you push it in, it never comes out. Okay, well, odds are that's not going to be a good shock for rebound. The shock has to return. It needs to return. The spring needs to return it. Okay, can't stay on the nose forever. Has to have some return value in the shock, or you might as well just put a rod on there. And when you do, when there's shocks like that, the spring load goes away from the tire and goes back to the lower control arm bolts. Okay, the spring is offset between the lower control arm bolts, the spring, and the tire. It's offset towards the bolts. So when the rebound becomes too high, it starts dumping load back to the bolts. Okay, virtually the tire goes away. So the car doesn't want to turn. So guys are saying, well, I put all this rebound in, it just sheared traction. It's because it's bad rebound. Okay, it's not bleeding out. It's got to bleed out some. So it's got to work in order for it to be any good. So a little bit about rebound. It's not everything. It's not always about killing bleed in the shock. It's not about stacking shims on top of a piston. Your shock guy needs to know a little bit about a race car. Ask him the questions. So often, you guys don't force the issue. Ask him the questions. There's no shame in asking. Okay, I've done this a long time. I was the type of guy that didn't ask questions. I didn't. But you got to ask questions. You can't solve the problem unless you ask why or what's going on or how's this work. You got to ask the questions. Okay, so if he just gives you rebound and goes, well, it worked for Joe Blow, well, that's not the answer. So if them are the type of answers he's giving you, it's time to go look somewhere else, because that ain't going to get you around the racetrack. So if it's working for you now, there'll be a day when it doesn't work for you anymore. And that guy, ask them the questions, make them tell you the answer. If they don't know, I mean, there's no we don't know. That's the problem. We don't know. We're learning every day. Okay, that's the problem. Some people have learned more than others quicker, and I mean, you know, I'm learning. I've learned more in the last 2 weeks than I've learned all year. You know, I feel like so. Maybe I'm a little slow, so I don't know. But I feel like you know we can work a little on the load numbers. We can work a little bit on the rebound, and we can make a car. You know, we're supposed to be tuning frequency from the spring with the rebounding. Okay, but when it comes to dirt, that never ever happens. Okay, and I'm not 100% sure that we can pull it off because the tracks are not smooth enough. Okay, technically we're supposed to tune the frequency of the spring to the frequency of the rebound. Okay, this puts grip in a race car. Okay, so we do these things through SRTs and just stuff we do, added rebound, the Gorilla Fist, the way we build them. So if you got questions, text me, Facebook message me.
Paul Harper said, can we run soft spring and ride on bump stop of shock?
Yeah, you can, but the problem is we're never on the bump like we think we are. So if you look at you know, go to the track, go find your photographer, give him $20 and tell him, sit right here and take pictures of my car at this point on the racetrack. And that point would probably either be right on entry or right on exit. Okay? And if you want them from the infield or the outfield, that's up to you. Outfield, you need to see that right front center off. Okay? And you need to see how much shaft is sticking out on that. Or you can put a GoPro on there and video yourself, or you can put data on your car and get really good information. But you need to understand where that right front shaft is, center off, on throttle, because it ain't where we think it is. So being on the bump is really difficult. His question was, do we need to be on the bump all the time?
Can we run soft spring and ride on the bump stop of a shock?
So we can, but we got to work on the rebound. I think, Paul, the problem is we're not loaded into the bump enough, and we lose so much when we go to the soft enough spring to stay on the bump. So a Gorilla Fist 500 would be that type of shock. Okay, I like the foam bumps better because they don't give you like this bump here. It doesn't give you much. I mean, you know, it has to be compressed all the way to the cup, and it doesn't get there until the very end. Okay, so this is what I like about it, because it does give you added value to the car. And if you really look at where our cars are on the racetrack, especially center off, we ain't as good as we think we are. We're not carrying as much wheel load, so the lateral forces are creating load to the tire, and the tire's just working on its own. Between moisture and the tire, it's working. So if we can start adding 100 pounds of load through the shock or the bump to the tire, now you're not getting a whole 100 pounds. We'll cover that someday. There's a motion ratio. I'll put something on the team page maybe tomorrow, Excel spreadsheet to do, you know, your down numbers. Okay, there's also a wheel calculator, you know, that figures lowers, bump stops, wheel spacers, you know, load at the tire, spring rates, you know. So I think I covered it all there. Like, you know, wheel offset, you know, an inch longer, lower. So you can figure all that stuff that figures load right at the tire. Okay, and you start seeing that when you go in there and you start changing that stuff, how much the tire is affected. Okay, the important part is what is it really going to take to make that tire turn and have grip center off, so we don't wash the nose up the racetrack. And I think it's a lesser number than all these big numbers we throw out, like 1,350 pounds, but because we ain't down as much as we should be. Yes, soft spring bump stop, that's the way it's supposed to go. You've got to stay on it, stay loaded 100% of the time. But I think we're probably better off if we're, you know, this is where we got to be careful. When we get in that go-kart stage of racing, when we put a car in posture and we're just bam right there, nothing moves in the car. So nothing no longer is dampening the tire other than the tire. Okay, And when you do this and you dampen the tire with something, the car gets way better. Okay, so that's one thing we got to keep in mind. So was there any other questions? Okay, so Rebound, if you have questions, call me, text me, call me tomorrow. I'm going to go home, watch the election. Encourage everybody to vote. It's probably too late for that. Should have done this earlier. It's not only our country that's in stake, it's our race, and it's in stake. More important though is our country. We really need to think about what we got. We've been blessed. God's blessed this country tremendously well, and we take it granted of that every day. So we need to start being more aware and thankful of what we have when we have it. It's a tough lesson to learn, but go home, go vote. If you've already voted, good job. Doesn't matter who you vote for, you need to vote, because if you want to be a part of something, you got to participate. So if you got questions about Rebound, let me know. Text me on Facebook, call me 620-326-3152. 2 Facebooks, it's J Neal or BSB Manufacturing. You can text me on, or so pray for our country. Off season's here. We got a lot to learn. We got a lot to do. So if you guys need anything, let me know. God bless you. As always, go fast. We'll see you next time.